All right, welcome back, guys. So we are currently in Unit 6. This is radicals. The first lesson pretty much involved looking at radicals graphically and then also solving radicals. But here, we are going to be performing operations on radicals for the next two lessons, basically. Um, and we'll be doing that with numbers. We'll also be doing that with variables. The first thing you should already know how to do is to get the perfect squares and the perfect cube roots and the perfect fourth and fifth roots of radicals. And so what we're looking for when we're looking for a square root is we're looking for a number that we can multiply by itself twice to equal 36, to equal the number inside of the radical. Um, you can go to your graphing calculator and do this. It's relatively simple, so make sure you have that for the remainder of this lesson. And I'm just going to clear out that and then press second x squared and put in 36 under that radical, and I get 6 is my answer. For the cube roots, I'm going to press math number 4. Okay, so for the cube root, I press math number 4, and there's a 125 inside of that radical, under the radical, and that equals 5. That equals 5. For the fourth root, I'm going to press math, and I think it's number 5. Number 5. And I'm going to have to put the number, the little index, inside of that radical. So math number 5, where that x is. So where I have answer, I'm going to put a fourth root radical. And the number that I have there is 2401. It's 24. I get under the radical, press 2401 or 2401, enter, and I get 7. This equals 7. For the fifth root, same thing. I'm going to press math number 5. Make sure you're writing this down. Math number 5, and the number inside is 1024. So math number 5, this is a fifth root radical, so I press 5 here. And inside of the radical, I have 1024. Enter, and that equals 4. Now, the parts of a radical, they have specific parts. So this number that I refer to is called an exponent. No, sorry, thinking about powers. This is an index. Now, I could rewrite this whole thing. Which I'll do in a second, but that's the index. That number, the 5, is an index. Now, inside of the radical, we have something called the radicand. The number inside is called a radicand. And this whole thing is called a radical. The whole thing is the radical itself. Now, if I was going to write the inverse, not necessarily inverse, but like what it could look like, this technically, 3x to the fifth root also equals 3 times x, parentheses, to the 1/5. So technically, we could be writing this inside of our TI-84s instead of trying to go to math number whatever to get these answers. Now, in the next part, we're going to do perfect radicals. It's just a replay of complex numbers. So I want you to recall when you have a negative number. Right? This negative inside, you're going to separate it. It becomes the square root of -1 times the square root of x. And this way we can evaluate both parts. You always put the number first. Put number first. And the square root of -1 is always equal to y. and the square root of negative 1 is always equal to I, put it last. Put it last, if possible, okay? So I'm going to switch these two things, and I have the square root of x, and the square root of negative 1 becomes I. It's like saying the square root of x times I. So when we're evaluating negative numbers under a square root radical, under an even radical, you be cautious and you be careful, okay? So square root of 36, we already did that. That's like saying the square root of 6 times 6, or this equals the square root of, or this equals 1 goes away, equals 6, right? Square root of negative 100 equals the square root of negative 1 times the square root of 100. All right. And that just equals 10 times I, or just 10I. Okay? Now the cube root, a little bit harder for me personally. So what I'm going to do is go to math number 4 and put in that number. It's a negative 512. For these do not produce complex numbers. Odd root radicals do not produce complex numbers. So this equals negative 8. This equals negative 8 for 4 times the square root of 49. So when you're in this situation, you just bring your number out. 4 comes out times the square root of 7 times 7. One of these goes away and the other comes out. This equals 4 times 7, or just 28. Okay. For the cube root of 64, this equals the cube root. I'm looking for 3 numbers, 4 times 4 times 4, or just 4 as your final answer. For the 6 times the square root of negative 25. So 6 times the square root of the negative breaks apart. So I have negative 1 times the square root of 25. All right, I'm going to skip a little step here. This equals 6 times, this becomes 5. The square root of 25 becomes 5. And this becomes I. I simplify by saying 6 times 5, or 30I. For G, this equals the square root of 11 times 11, or just 11. For H, this equals 5 times the cube root of 729. So I'm going to go to my graphing calculator because I can't do that in my head. If I did, I might make a mistake, and I don't really want to make mistakes unnecessarily. Math number 4, 729, enter, and I get 9. 9 as that cube root. So 5 times 9, or 45. For the next one, we have to be careful. So we expand variables. Expand the variables, and we're looking at a square root radical. So we're looking to take one away and bring one out. All right. So I have this equals 2x, and I have times the square root of 4. Then I have times the square root of, and I'm going to write this out, x times x. Some things I know how to do, right? But let's just bring it down. Bring what I have down. I have 2x. The square root of 4 is 2. the square root of x squared. I take one away, one comes out of the radical, is x. Now I need to simplify. 2 times 2 is 4. And then x times x is x squared. So here's my final answer. Okay? So that's your first page. That's your first page. The next page, we're going to look at not so perfect radicals. How do we do that? Well, the example we have here is the square root of 18. So if we broke that down, we're using the tree fashion, what I call tree, and we break it down into its prime factors. I create a little tent underneath, and I always start with my smallest primes, which is 2, 3, 5, 7, 11, 13. Basic small primes, right? But 18 smallest prime is even, and it's going to be 2. 18 divided by 2 is 9. Now I need to break down this 9, so smallest prime I have is 3, and then all my primes are in blue. They're all in blue, so I'm going to rewrite this with the prime factors. If you're not recognizing the prime factors, this is a prime, this is a prime, and this is a prime factor. So this equals 2 times 3 times 3. Now what we do is we identify our pairs. Anything that comes in a pair, we're working with a square root radical. Anything that comes in a pair, you take one away and you bring the other one out. Now that 2 is going to stay inside though. This equals 3. One goes away, one comes out. Square root of 2. Simplified. But you can also use the graphing calculator. So in y equals, we type the radicand divided by the variable raised to the index. So the index here is 2. So we're going to identify those two things each time. And so I'm going to have, in my calculator, I'm going to have y1 equals 18 divided by x squared, right? Well, what we're going to do is we're going to press second graph and go to the table. And what we're looking for is the lowest whole number in y1. So the lowest whole number in y1. So it wouldn't be 18. Wouldn't be anything underneath that. But the smallest whole number is 2. On the other hand, x has to be a whole number too. And what you'll find is, what you're going to create is, you're going to have your x value, and your smallest y1. So anything under a radical, so any number under a radical is going to be your x value times your smallest y1. And both of these numbers have to be whole numbers. So we're going to try this with square root of 18, and we should get 3 square root of 2. So I press math, second x squared, and I'm doing 18. Oh, no, not the radical. Press alpha, y equals, we're putting in a fraction here, 18 over x squared. And we're going to write this out every time just to make sure that you are putting it in correctly. Second graph. It's not what I want to do. I don't want to graph it. I just want to look at the table. Okay? So if I go up, these numbers, I have no negative number can ever be your whole number for x. So it's only it can only be positive numbers. So no negative number when it's a square root, that is. When it's a square root, okay? But if you look, these numbers keep getting smaller and smaller. It's just nothing but fractions. And it looks like my smallest y value is 2, and the matching x value is 3. So my answer is 3 square root of 2. And we're going to do this a couple times so you get this down. So first, what I'm going to do is go through and figure out what I'm going to put in y1. So for number 20, y1 is going to be that number, the radicand inside, divided by x squared. For letter B, I'm going to have 243 doesn't equal that. But in y1, I'm going to put 243 divided by x cubed. All right? And for letter C, I'm working with a negative, and it's not a perfect square. So I'm going to rewrite this and write the square root of 98 times I. And I can't forget about that I, so I'm going to put that in red. All right. And then for y1, I'm going to put in 98 over x squared. All right. For letter D, it's the cube roots. What I'm going to do is, instead of here, this is complex because it's square root and it's negative. Here, bring out the negative. So I don't make any mistakes. So that's the best thing to do. So this equals negative cube root of 5,000. So in my calculator, I'm going to put y1 equals 5,000 over x cubed. So I'm just going to focus on these first 4 problems. And then we're just going to go back individually and do the problems, some of the problems on the bottom. So first one is 20 over x squared. I'm looking for my smallest whole number y value. So I'll go back to y1, clear out what's in there, write alpha y equals, enter, 20 over x squared. And I press second graph and go to the table, looking for my smallest y value. So I see a bunch of fractions. I'm just going to go down and make sure that that's my smallest fraction. And remember, none of these should be negative x values, right? Not in the calculator. So my smallest y value is 5. That matching x value is 2. So if you don't see it, it's right here. So when I write my answer, I'm going to have 2 square root of 5 as my answer. 2 square root of 5 as my answer. So go back to the, I messed up a little bit. There we go. There we go. So the correct answer here for the square root of 20 is 2 square root of 5. Here's my correct answer. The next one is going to be 243 over x cubed. So clear that out. Alpha y equals, enter. Oh, alpha y equals, enter, 243 over x up arrow cube. Second graph, and my smallest y value looks like 9 so far, but if I keep going, it has to be 9. And the number x value paired with 9 is 3. So you be careful because this index is 3, and your answer is going to be 3 square root, the square root radical, but it's going to be a cube root. So that's my answer. Okay, next one, don't forget about the I up there, but you're going to put in your graphing calculator 98 over x squared. Do not put the negative number. So I'll go to y1, clear it out. Alpha y equals, enter, 98 over x squared. Second graph, and I find my smallest whole number y, looks like 7 and 2. So here, I'm going to have 7. My I comes out, doesn't stay inside of the radical. 7i square root of 2. And pretty soon you'll get used to where this I goes in this configuration. But for now, let's do the next one. It's the cube root of negative 5,000. Remember, we bought the negative out, so I'm going to just go ahead and write that out. Negative goes out here. And figure out what my numbers are. So y, and I have 5,000, and the x is cubed. And I'm looking for my smallest whole number y. And looks like not 2, not 625, not 40, maybe. Let's keep going down. And I see 5, and 5 is a prime. So 10 square root of 5. And if you notice, 10 cube root, this is a cube root of 5. If you notice, we're looking for a smallest prime at times, sometimes not, but yeah, we'll go with that. E, F, G, and H. E, F, G, and H. So for E, I'm going to have 27 over x squared in that calculator. So I'm going to go to graph and calculator, press y equals. I have 27. I'm going to delete those two to zeros. Go down, make sure it says x squared. Second graph, and I'm looking for my smallest whole number y. And it's 3 and 3. 3 is matched to 3. So I have this equals 3 square root of 3. For F and G, I'm going to allow you to do those on your own. For H, I want to do that one with you. So if I rewrite this, I have 2 times something. But in my graphing calculator, I'm going to put y1 equals 63 over x squared. I'm looking for my smallest whole number y, and I have 63 over x squared per second graph. And if I go down, I have 3 and 7 is paired, and the rest are fractions. So I have 7 is my smallest whole number y, and 3 is paired with it. So that gives me 3, but inside that radical, square root of 7. All right? So I just need to simplify. I need to simplify. 2 times 3 is 6, square root of 7. So you do F and G for the practice. I'm going to do A, and I'm going to do, actually, you're going to do A. So just make sure you're putting in y1 equals 180 over x squared. Over here, y1 equals 588 over x squared. For C, we're going to do C and D. We're going to have 1944 over x cubed. And for D, we're going to have 268, 912 over x to the 4th, right? So 1944, see, 1944 over x cubed. So we're doing C, 1944 over x cubed. And I go second graph, looking for the smallest whole number y. It looks like 9 might be it, and 9 it is. 9 is paired with 6. So make sure you're using that radical. So the cube root of 1944 is 6. The cube root of 9. For the next one, we have 268,912. The fourth root of that, okay? So at the top, I'm going to go put this number in, 268,912 divided by that index, x to the 4th. Second graph, all right? Looking for our smallest whole number. So it looks like 112 is a whole number. 7 is a whole number. And that looks like it's it. That's just 7. So 7 is paired with 14. So if I rewrite this, I have 14, the fourth root of 7. If you are confused, you need to go back and play back that video. Okay? Now, with variables, that's what we're going to do next. You're going to expand variables. Now, I'm going to show you what we're looking for here before we move on. So if we have, let's say we're going to take this this term, okay? And we're going to do it under the square root radical. We're going to do it under the cube root radical, as well as the fourth root radical. And let's even do it under the fifth root radical. So each one, we're evaluating the term x to the 8th, and we're looking for different types of variables in groups, different groups of variables. So for the first one, we're looking for groups of 2. And what we're going to do is to expand x times x times x times x times x. So that I wrote it out. There's 8 x's. Now, you could also rewrite this as x over 8, x to the 8th divided by 2, which equals x to the 4th. Okay? But if you're struggling with that kind of manipulation, you can expand it out to where there's 8 x's. Now I'm going to count the pairs, and what I'm going to do is just underline the pairs in different colors. So here I have a pair, here I have a pair of x's, here I have a pair of x's, and here I have a pair of x's. Now what happens? Well, one in each pair goes away, and the other variable comes out. So here, out of the radical, so I have x times x times x times x coming out of the radical, right? And this equals x to the 4th. That's what I have above. Now let's say I wanted to skip expansion. You could rewrite, becomes x to the 8th over 3. That's like saying x to the 6th over 3 and x squared inside of the radical. Except this is a cube root radical. All right? Technically, I should get x squared coming out, and inside I should have 2 left over. That's what I should have. So let's see. In here, we're looking for groups of 3. So I'm expanding it out. So I showed you the way that I would do it, the way I'm used to doing it. It's shorter, but we're going to do it this way. So we're looking for groups of 3. Here's a group, and here's a group of 3. But what stays inside of the radical? These 2 x's. So I'm going to rewrite that, right? But those 2 x's stay inside of the radical. And I have x right here. X times x coming out of the radical, but inside of the radical, and it's a cube root radical, I have x squared. Simplifying this answer, I have x squared, cube root of x squared. What about x to the 4th? Well, we could rewrite it, becomes x to the 8th over 4, or x squared. That's my final answer. So we're looking for groups of 4. We're not going to do x to the 5th root of this because I don't have space for it. Groups of 4, right? Here's a group of 4, here's a group of 4 that leaves me with x. Sorry guys. Times x or x squared. So you can replay that to kind of see how to work with radicals under a variable, but we're going to move on. to the next part. So if you see, I used that technique that I was talking about earlier, and we could still do that. Um, but so we have, I'm just going to separate each one. So separate each part. Separate each part. It's easier to work with. Okay? Um, so I have this equals the cube root of 27 times the cube root of x cubed times the cube root of y to the 6th. Now, a cube root of x cubed is not 9, it's 3. It's 3. You can use your graphing calculator for that. On the other hand, the cube root of x cubed, that's like saying, okay, the cube root of x times x times x. Well, count the number of pairs there. I mean, triplets. Triplets, your index is a triple. And you have one triple, okay? But we're going to do that in a second. And then we have the cube root of y times y times y times y times y times y. Right? Count the number of triples. I have 1 and I have 2. So what happens? This becomes 3. The x comes out. The radical completely goes away for that. Then I have 2 y's, 2 triples of y. Final answer is this. So make this smaller. Okay. Next one, we're looking at 2 eighth root of x to the 8th. And I'm not going to do all those numbers. So what I'm going to do is say 2 times x to the 8 over 8 to the power inside divided by the root index outside. So the power inside divided by the root outside. It makes it easier to simplify. This equals 2x to the 8 over 8, 1, or just 2x. For the next one, we have 4. And then on the inside, I have, so I'm going to rewrite this. So it's like saying 64 to the 1/3. There's a 1 here. And this is like saying a to the 3 over 3 times b. The power inside is 9. The root outside is 3. So I rewrite this. I have 4 times 4. This equals 4. And a to the 3 over 3, or a to the 1 power. And then b to the 9 over 3, or b to the 3rd power. Simplify, this is 16ab cubed. Okay? So some problems that are not so pretty. Some problems that are not so pretty. So we're going to be using pretty much the same techniques. But these radicals are not perfect. So first I'm going to figure out what this is. So I'm going to do parts. Square root of 50. So in my graphing calculator, I'm going to put y1 equals 50 over x squared. And then I'm going to evaluate x to the cubed. X to the cubed. And I'm going to get 2 times something. So I'm going to go to y1 in my graphing calculator. Put in, let's clear this whole thing out. Alpha y equals, enter, 50 over x squared. We're looking for a smallest y1. And so far I see fractions, so I'm just going to go up. And it looks like 5 square root of 2. That's what my radical is. It's times 5 square root of 2. And then I want to focus on what's inside of here. So I'm going to go back to expanding out x times x times x, right? And what I get when I simplify, there's only one pair of x's. So the other x, what we're going to find is that it stays inside. That lone x stays inside because there is no number to pair it with to push it out. So this simplifies to 10. 2 times 5 is 10. The x comes out. The square root of 2 times the square root of x. Simplifying, I get 10x square root of 2x. So if you noticed, anything that came out, I put it together. Anything that stays in the radical goes together as well. So we're going to do the next one in the same way. Y1 is going to be 128 over x squared. And I'm going to separate everything else. So I have the square root of 128, the square root of x times x times x times x times x. And then lastly, I have the square root of y. There are no pairs for y. Now, y1, I'm going to go ahead and put that in there. A lot of steps here. So I have 128 over x squared. Second graph. And we're looking for that smallest whole number y. And it looks like it's going to be 2, 8 square root of 2 here. Now, my pairs of x's, I have 1 and I have 2 pairs. And then I have one lone x value. So I'm going to have x squared square root of x and then times the square root of y. So things that are going inside of the radical. This is going inside, this is, and this is. That means I'm going to push that 8 and x squared together. This equals 8x squared square root of 2xy. Okay? So for g, I'm going to go to y1, put in 54 over the index, x to the index, or x cubed. But inside, I'm going to have x to the 5th, y to the 7th. So when I simplify this, you should have 3 square root of 2 as for that simplified square root of 54. And then you have x to the 5th over 3 and y to the 7th over 3. So we're going to do this in a different way, a little bit different, right? And this equals 3 square root of 2, right? And I'm going to ask myself, how many threes are in 5? There's only one. There's only one. So it comes outside, but inside you get the cube root of x squared. Then you're going to ask yourself, how many y's are in 7? How many y to the cubes are in 7? How many 3's are in 7? And that's going to give me y squared. But inside, 7 minus 6, I have 1 left over. So what I'm going to do is combine. I have 3x y squared times the square root of 2x squared times y. That was very complicated for no reason. H is a square root, so I have rewriting x to the 10th divided by 2, y to the 8th divided by 2, z to the 12th divided by 2. This one's fairly simple. X, this is going to simplify to 10 to the 2 10 divided by 2 is 5. For y, 8 divided by 2 is 4. For z, 12 divided by 2 is 6. For higher roots, you're going to do these on your own. Just remember to separate, right? Let me rewrite that real quick. But these you do on your own. Just separate each term and simplify. Okay? Go back and look at the video if you need to, but separate and simplify. So the last part that we want to do here today is multiplication. And I'm going to create another video for this part, multiplication, and we'll go from there. Okay? All right.